Hey guys, welcome back to Limitless Learning. Today we'll be talking about composition of functions and we'll be going through some examples. You might be asking, what do I mean when I say composition of functions? Well, composition of functions refers to a function h of x that is composed through the combination of two other functions, f of x and g of x. As you can see, the notation is shown below, in which there is two ways to show that h of x is composed of f of x and g of x. When describing composition of functions, you would say f of g of x equals to h of x. Now let's go through some examples to find out how to apply this concept. For the following examples, determine values for each of the following knowing that f of x equals to x squared plus 1 and g of x equals to 3x minus 4. For example 1, we need to find f of g of 0. So in these problems we work from the inside out. So thus we'll need to find what g of O means first. So thus we substitute 0 into g of x. So that would be g of 0 equals to 3. We substitute the x in 3x minus 4 with 0. So 3 times 0 minus 4, which equals to negative 4. Then you could substitute g of 0 with negative 4 into the equation, which will leave you with f of negative 4. Then we'll substitute negative 4 into f of x, just like we did with g of x. So that will equal to f of negative 4 equals to negative 4 squared plus 1, which equals to 17. Then, question 2 asks g of f of 1. Now you know how to solve these types of equations. Pause the video and try to solve it, and then come back to the video so I can show you how to solve it. Alright, so like the first question, we're going to first try to find out what is f of 1. So if we substitute x for 1 into f of x, you will get f of 1 equals to 1 squared plus 1, which just equals to 2. Now you can substitute 2 for f of 1 since they both are equivalent. So if you substitute 2 back into the equation, you will be left with g of 2. So just like the first calculation, we're just going to have to calculate what g of 2 is. So we'll substitute 2 for x. So that would equal to 3 times 2 minus 4, which equals to 2. So now we know that g of f of 1 is equal to 2. Okay, so now we will try to solve two questions that only require one function, one of which has a different notation than the prior examples. So similar to last question, we'll pause the video, you try to solve it on your own, and I'll answer afterwards. Alright, so the first step would be to find the inside function, so you would find out what g of 2 is equal to. So although we already did this in the prior example, I'll just show the calculations. So it will just be 3 times 2 minus 4, which is equal to 2. Now you can substitute 2 for g of 2 into the equation, which will also just be left with g of 2. So now we did the calculation already prior in the question. We can just save this and put this into the overall equation. So you are left with g of 2 equals 2. So that would be the final answer for this equation. Now for 4, as you can see, it's a different notation than normal, but this just basically means f of negative 2. So sometimes either exams might trick you with this, so just make sure to know the difference between each notation. So now that we converted it into the notation that is more suitable, we can start to apply our calculations. So first work on the inside, try to find out what f of negative 2 is. So substitute negative 2 for x into f of x. So that will be negative 2 squared plus 1, which is equal to 5. Then you can substitute 5 into the equation as f of negative 2. So you are left with f of 5. which is equal to 5 squared plus 1. And once you calculate that, you'll get the answer to be 26. Although we have only seen this used for straightforward problems, we can also use composition of functions through graphs. We'll look through a couple of examples using this. So looking at the graph, the red function is f of x, which equals to x squared, while the green function is g of x, which equals to 1/2 of x minus 2. Using this, question 1 asks us to find f of g of negative 2. So just like last time, we first find g of negative 2 on the graph. So g of negative 2 seems to be around negative 3. So we'll substitute g of negative 2 with negative 3. So now you're left with f of negative 3. However, when we try to find f of negative 3 on the graph, it doesn't seem to be a point on f of x. So thus, f of negative 3, or f of g of negative 2, does not exist. So you would just put DNE for this problem. So now I will let you guys try to question 2, which asks us to find g of f of negative 2. So pause the video, try to solve it, and then come back once you have finished. Alright, so just like last time, you would start with the inside function. So f of negative 2, it seems to be that f of negative 2 is equal to 4. So we would substitute 4 into the equation. So now we're left with g of 4. So if you substitute 4 into here, you'll see that 4 is equal to, although this is a very thick line, you can see that it is around 0. And if you plug it into the equation, you'll also see that it equals to 0. So overall, g of f of negative 2 or g of 4 is equal to 0, which is our answer for this question. So in addition to plugging in numbers for the inside function, like we did in the previous problems, we can also simply substitute equations into one another. So let's look through a few examples for how this would look and how to solve it. So for the following examples, determine the formulas in simplest form, knowing that f of x is equal to 2x minus 3 and g of x is equal to 4x plus 5. So for example 1, it asks us to find f of g of x. As we know, g of x is equal to 4x plus 5. This would equal to f of 4x plus 5. So this would be where we substitute 4x plus 5 for every x in the f of x function. So thus it would equal to 2 times 4x plus 5, since we're substituting that for x, minus 3. Now if we use the distributive property, we'll distribute 2, which would equal to 8x plus 10 minus 3. Now if you just combine like terms, you'll be left with 8x plus 7, which is your final answer. Now try this problem on your own, which is where we're trying to find g of f of x. Pause the video and then come back once you have solved it or if you need help. Alright, so just like last time, we know that f of x is equal to 2x minus 3. So we can substitute that into the equation to find what this equation is. So that would be g of 2x minus 3, where we substitute 2x minus 3 for every x. So that would equal to 4 times 2x minus 3 plus 5. Now if we distribute the 4, we will get 8x minus 12 plus 5. Combine like terms will get us 8x minus 7. And that is your final answer. Thank you guys so much for watching. If this helped you, like the video and subscribe for more content. Leave your comments down below if you have any questions or any ideas as to what videos we should make, and we'll see you guys in the next video.